So, for today's lab, you guys are going to be testing to see if chemicals have energy. You have been given a task from Schneikes. If you guys look up here, if you've been given a task, doo, 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 from Schneikes, a mitten manufacturer, to design and create the world's warmest hand warmers. You will be investigating two different combinations of chemicals to see if they have energy. So, your first combination is calcium chloride, which is a fancy way of saying salt, and water, which is also known as H2O. Okay, so calcium chloride and H2O. Your second combination is sodium bicarbonate, fancy way of saying baking soda, and acidic acid, which is a fancy way of saying vinegar. Okay, so salt and water, baking soda, and vinegar. You have two different combinations you're testing today. Okay, so after your investigation, you're going to choose between the two to determine which will work the best for the new hand warmer of their new mitten design. Cool. Okay. So if you look, you have a materials list. Someone from your group will be assigned the materials manager. They will come and get your tray and it will be filled with what you need. Okay. For part one, the very first thing that you're going to do is focus on the fact that you're only working with the calcium chloride and the water. And if you remember from up here, your calcium chloride is just the salt. Okay. So salt and water is the only thing you're mixing right now. Okay. You're going to start off with a prediction. So don't touch anything, don't mix anything. You are just predicting. You're looking at the fact that you are working with salt and water. What do you think or what do you predict will happen to the temperature when you mix those two together? Okay. It's a prediction, so you're not going to really know. Don't stress about it too much, but you're trying to predict, do you think the temperature is going to increase, decrease, and specifically by how many degrees? So talk about it in your group and then record your prediction. Your prediction does not have to match everyone else in your group, but you're talking about it with your group members to at least get some ideas flowing. Maybe someone has thought of a reason why their prediction could be correct and it could get your brain thinking in that direction. But no, you do not have to match in your predictions, okay? So pause the video if you need to. And then go ahead and move on once everyone has recorded their predictions, okay? So for part two, you have your procedure listed, right? We're still just working with our salt and our water, right? CaCl and H2O. So it's really important that you go step by step. You don't skip any parts. Okay, so I'm going to walk you through this. Step one of your procedure is to measure 10 milliliters of water and pour it into your graduated cylinder. So this is important. For every step that you're measuring, one person can be in charge of measuring it and saying, hey, I think this is worth 10 milliliters. But everyone in your group is responsible for checking that measurement before moving on. Okay, so no one can be blamed in this lab that, oh, well, that was your part. Okay, everyone's responsible for every single step of the procedure. Cool. So one person can measure out the 10 milliliters. Everybody else is going to check to make sure they agree it's 10 milliliters of water. And then you're going to move on. Okay. So once you've all agreed, you're moving on to step two, which is to take the temperature of that water. Okay. Once you've taken the temperature, everyone needs to agree upon the temperature. You're going to record it in the before section down below in the table. Okay, so I'm going to show you. This is your table, right? And this first little column is your before temperature, right? So you're going to take your before temperature of your water and record it right here because water is H2O. Cool. Okay, that's why it's called step two right here. Okay, so you're going to record your temperature. Then once you've got it recorded, then everyone moves on. Okay, it's not like someone's doing part one, someone else is doing part two at the exact same time. Do each step one at a time. Okay, so once you've got it measured, you've got it recorded, then you're ready to move on to step three altogether. So now one person can measure 1 scoop of the salt, the CaCl, and carefully pour it into the plastic bag. You're not pouring it into the graduated cylinder, okay? Make sure that you're putting it where it belongs. That's why I highlighted it in yellow, just to help you out, okay? So 1 scoop of salt, pour it into your plastic bag. Measure and record the temperature of the salt in the before table below, okay? So again, CaCl, 2 is your salt. And this is where you're going to record the temperature. Once it's recorded, everyone's agreed that that was the before temperature, then you can move on to step 4. Okay, so step 4, someone is going to take the water from that graduated cylinder and pour it into that bag. Okay, this part you need to kind of do quickly. So you're going to pour it into the bag, push out the extra air carefully, and seal the bag. Okay, so you just don't want it to be a big old poofy pillow, but you're trying to get most of the air out if you can, and then seal it. Okay, then have someone ready to take the time with the iPad, with their watch, whatever they're going to do, and wait 30 seconds. Okay, after 30 seconds, you don't open the bag. Without opening the bag, after 30 seconds, you're going to record the temperature again. So this is kind of your mixture temperature, right? And if you notice, we're on step 5. So if you look down here, step 5, temperature after you mix them. So that's why there's a plus sign here. We took our salt and our water and we added them together. So what's your after temperature? Cool. Okay. And then step 6 is just record any other observations while observing the reaction. You shouldn't have a smell because the bag is sealed, but did you notice anything visually? If you did, just record it in your observations. Observations are a huge, important part of any science procedure. Okay. And then I went through and I said, hey, for step 7, use a calculator and find the difference between your before and after temperatures. So if you can't remember what difference means, it means you're going to take your before temperature and subtract the after temperature, or you're going to take your after temperature and subtract your before. Just kind of depends, but it will be a subtraction problem. Okay. To find your difference, you're going to subtract. It just depends on if your temperature went up or down. Okay. So you're going to subtract the difference between these and put it here. Once you have all of that recorded, everyone in your group has it recorded, you can move on. So pause the video if you need to right now, and then move on when you're all done. Okay, so if you are ready to move on to part 2, it means everyone in your group is ready. Okay, part 2, you are moving on to a completely new mixture. So all of your old supplies need to be cleaned out of the way, gone. Okay, so that way you don't accidentally mix anything. So right now you're going to move on with acetic acid, which is vinegar, and sodium bicarbonate, which is baking soda. Okay. Again, before you mix anything, you're going to predict. Every single person in your group needs to stop and record their prediction. What will happen to the temperature when you add this vinegar and baking soda together? Okay. Your predictions don't have to match in your group, but everyone needs to write one down. Okay. Talk it out. Do you think the temperature is going to go up or down? By how many specific degrees? And why do you think that? Because maybe your reasoning will help someone else in your group make a better prediction. So share out, okay? Pause your video, talk it out, record it, and then come back. Okay, so now we're ready to move on to the actual procedure where we're going to measure and mix our vinegar and our baking soda. Okay, so again, every single person's responsible for each step. You're not doing multiple steps at the same time. Okay, it's not a divide and conquer type of scenario. With the lab, it's important to go one step at a time. It's not like a group project where you like divide everything up. Okay, it needs to be done in order. So the very first thing you need to do is have one person measure 25 milliliters of vinegar into a graduated cylinder. Once they think it's 25 milliliters, everyone in the group needs to check it, get down, check it at eye level, make sure it's 25 milliliters. Everyone agrees, and then you can move on to step 2. Step 2 is to take the temperature of that vinegar and record it in the before section below. So if you look, If we're looking at vinegar, that's your acetic acid, right? So that's your before temperature acetic acid. You're going to write it right here in your table. Okay. Once everyone has it recorded, move on to step 3, which is measure 2 scoops of the sodium bicarbonate, which is baking soda, right? Measure 2 scoops of baking soda and put it into your plastic bag, not the graduated cylinder. Put it in your plastic bag and then record the temperature of that and put it in your before section down below. So 2 scoops and then record the temperature of it in the plastic baggie down here below. Once everyone agrees on the temperature, everyone has it recorded, move on to step 3. Move on to step 4. For step 4, you're going to take the vinegar, right, that was in your graduated cylinder. You're going to take that vinegar or acetic acid and pour it into the bag. Have someone ready with the stopwatch when you're doing this pouring, okay? That way you can do it pretty quickly. So you're going to pour that vinegar into the bag, carefully push out any extra air that you can, just so it's not a big fat pillow of air, and seal the bag, okay? As soon as it's all sealed up, you're going to wait 30 seconds. So someone time it out. Don't open the bag, but after 30 seconds, record the temperature, okay? And that goes in your after temperature column, and record any other observations that you have. So again, this is where you're going to record the temperature after you add them together. And then any observations. So did you notice anything visually? Again, you shouldn't smell anything because it's a sealed bag, but maybe there's something visually that you could describe here. Okay. So once everyone has the temperature recorded and observations recorded, you can move on. So pause the video here, do what you need to do, and come back. Okay, the very last step that I would have is, I just realized I need to kind of change this. So instead of it saying record any observations, because I already have that up here, record any observations. So your very last step should basically be the same thing as up above. You're going to find the difference in temperature, right? So what was your before temperature versus your after? So it's going to be a subtraction problem of some kind to figure out the difference in temperature here. Okay. And that's just to kind of give you an idea. Did the temperature go up when you mixed them together? Did it tend to go down? And that is the end of your overall lab of determining which one you will be using to create the best hand warmers for this mitten design. So as a group, determine which one would be better. Would it be better to have salt and water, or would it be better to have baking soda and vinegar? You guys talk it out. How much of a difference did you have? Which one was it like a clear, obvious choice, or were they pretty close to one another? I don't know. You guys talk it out. That will be your flip at the end of class. You guys as a group can record one flip together that just gives us your overall temperature difference for each mixture and which one you would choose, mixture 1 or mixture 2.